Good morning everyone. In this video we are going to discuss about some of the method for the preparation of alcohol. So we are starting with the preparation of alcohol from alkene, that is called acid catalyzed hydrolysis of alkene. When alkene is treated with water, that is the acidified water, it forms CH3CH2OH, that is an alcohol. The reactant is ethene and the product is ethanol. The reaction follows the Markovnikov rule. Sometimes you ask that why the acidic medium? Whether water alone is not capable to proceed the reaction? Surely, water is capable. But when you will see the dissociation of the water, what is the amount of dissociation of water? You will find that the water have very low dissociation. The dissociation constant for water is 10 to the power minus 14. That means the amount of dissociation in the case of water is very low. So to increase the amount of dissociation, to increase the rate of reaction, to increase the yield, we add the acid, especially the sulfuric acid. Now, how the reaction will proceed? For this reaction, the mechanism is important. So, we are going to discuss an important mechanism on the exam point of view. So, how the reaction proceeds? So, this is the water which reacts with acid to form the hydronium ion. You can say this is the attacking group. So, this step is called the generation of attacking group. We are discussing about the mechanism. Now, this attacking group will approach on the alkene. This is the alkene, CH2 double bond CH2 plus H3O positive. And when this alkene will approach on the system, what will happen? It will make CH2 single bond CH3 positive plus water. You can ask that why the hydronium ion is approaching, why not the hydroxyl ion? That can also approach, surely that can approach. Then why the hydronium ion is approaching? Actually, when you will see a cation is there, so that will search for the negatively charged center and the anion will search for the cationic center. So, whether there is any cationic center in the system, you can see that the system is perfectly neutral. There is no charge, neither the positive charge nor the negative charge in the case of the alkene, in the case of the ethene. But there is a double bond, which is an electron-rich system. So, that double bond will participate in the reaction and the double bond is considered as a negative charge, considered as an electron. So, that will approach on the cationic portion. So, it approaches on the cationic portion. Now, this one, that is the CH3, CH2 positive will again approach on water, having two lone pairs. And when it will approach, it will form CH3, CH2O, H2 positive. And for the neutralization of the system, the bond will break and will generate CH3, CH2OH along with the H plus ion. And this is the mechanism for the acid catalyzed hydrolysis of alkene. I think it's clear to all of you. You can just note it down or take the screenshot. The next way to prepare the alcohol is the hydroboration oxidation. In this process, we go through two different steps. The first step is the hydroboration, which is followed by the hydrolysis, which is followed by the oxidation to form the alcohol. This reaction follows the anti-Markovnikov rule. That means the hydroxyl group approaches at the carbon having greater number of hydrogen. So, we are proceeding the reaction, we are trying to proceed the reaction. This is an unsymmetrical alkene CH3CH propene, when it is treated with hydroboration, I am taking BH3. Generally it survives in the form of the B2H6 because it survives as a dimer being a electron deficient system. So when we will take the BH3, it will combine, there will be an addition reaction, one of the hydrogen will approach on the alkyl group and it will form CH3, CH2, CH2 and BH2. That is a propyl hydroborane. Now again, one of the another propene will approach on the system, that is the CH3, CH2, CH2, BH2 will approach on the CH3, CH double bond CH2, and after combination again the same reaction will take place. One of the hydrogen will approach at the carbon number 2 and the boron will approach on the carbon number 1 and it will form CH3, CH2, CH2 twice BH. In the next step, one of the another propene will again approach. So this is the CH3, CH2, CH2 twice BH will again approach on the CH3, CH double bond CH2 and after approaching it will form the same reaction will again take place and the product will be tripropyl borane. Now this compound undergo the hydrolysis. This is the compound CH3, CH2, CH2 thrice B. For the hydrolysis we are using water, H2O2 and one of the oxidizing agent and it will give CH3, CH2, CH2OH along with BH3. Then this is the overall hydroboration oxidation reaction, one of the important reaction in this chapter. The same reaction, that is the hydroboration oxidation, can also be written in the lesser number of steps. So here we are seeing when you will take 3 alkenes, that is the 3 moles of the propene along with the BH3, we are writing all the 3 steps in a single step, it will form tripropyl borane. And this compound on hydrolysis, the same step will proceed as in the last step of the first way. In presence of H2O, H2O2 and oxidizing agent and acidic medium you can take, it will form CH3, CH2, CH2OH along with BH3. The reaction is same, but in the previous way we have proceeded the reaction in the different steps and we are using the lesser number of steps here. The reaction is same, everything is same, you can use any of the method, even the previous method is the better method and this one is a shortcut method for the same process. The next process for the preparation of alcohol is from haloalkane. We have already discussed in the last chapter. The reaction is called the substitution nucleophilic reaction, which was called SN reaction. We have discussed the mechanism for the reaction, that is the SN1 mechanism and SN2 mechanism. So we are going to discuss the preparation. Actually we have already discussed, so I am just writing the reaction. This is the reaction CH3, CH2, OH. When it is treated with potassium hydroxide under aqueous medium, it's necessary to write that the reaction is proceeding under aqueous medium. Why? Because in the alcoholic medium, when the reaction will proceed, the elimination will dominate over substitution. And when elimination will dominate, it will not be the alcohol as a product. It will be a alkene. So to avoid the preparation of alkene, to get the dominant yield of alcohol, we use the aqueous KOH. So we are using the aqueous KOH. Simple substitution reaction will take place and it will form CH3 CH2OH along with KCl. Sorry, this was the haloalkane. I have written alcohol, गलती से लिख दिया था. Then this is the way for the preparation of alcohol from haloalkane. Now, how will you prepare with the help of the Grignard reagent? What are the Grignard reagent? We say alkyl magnesium halide is called the Grignard reagent. लास्ट चैप्टर में हमने उसके प्रिपरेशन के बारे में पढ़ा था. इस चैप्टर में हम देख रहे हैं कि how to prepare alcohol with the help of the Grignard reagent. And which of the reactant will be needed for the preparation of alcohol with the help of the Grignard reagent? It will be aldehyde or ketone. जब भी आप aldehyde या ketone को Grignard reagent से treat करेंगे, it will be alcohol. So we are trying to see. I am taking both the example, that is the example of aldehyde as well as the example of ketone. Then first I am starting with the aldehyde. Generally, when we treat aldehyde with the Grignard reagent, it will be the secondary alcohol, but in the case of methanol it will be primary alcohol. So I am taking a ethanol compound which will aid the secondary alcohol. So this is the ethanol CH3 this is CH3 CH double bond O reacting with CH3 MgBr. When the reaction will take place, this bond will break and will form CH3 CHO negative, and surely there will be the CH positive. The positive charge development will take place, and when you will see this one, this is the organic compound, so this bond is going to break, CH3Mg bond. When it will break, the magnesium, which is a metal by the nature, will generate positive charge over itself and will approach on the oxygen. And the alkyl group, which is respectively negative, that will approach on the carbon and will form this one. Now we will proceed the hydrolysis. We will hydrolyze the substance, and when you will hydrolyze, it will give CH3 CHOH CH3, a secondary alcohol. Along with that, it will form MgOH Br, that is the magnesium hydroxyl halide. But what happens when you take the Grignard reagent? With the help of the Grignard reagent, how will you prepare the alcohol? Grignard reagent along with the ketone. How will you prepare the alcohol with the help of the Grignard reagent and ketone? So this is the ketone. Propanone, well known as acetone, is treated with methyl magnesium bromide. And when it will approach, the same step will proceed. Whatever proceeded here, it will form CH3C O. With the oxygen, it will be the magnesium halide, and with the carbon, it will be the alkyl group. Now, this alkyl group, alkyl oxomagnesium halide, will hydrolyze, and when you will hydrolyze this system, H2OH plus, it will form CH3C CH3 CH3, and this one will hydrolyze to form OH along with Mg OH and Br, magnesium hydroxyl halide. Then this is the way to prepare the alcohol with Grignard reagent on reaction with aldehyde as well as on reaction with the ketone. The next reaction, we are going to see the preparation of alcohol from the carbonyl system. Carbonyl system means aldehyde and ketone. Sometimes it is asked that whether the carboxylic acid is also a carbonyl system. Surely the carboxylic acid is not considered as a carbonyl system because of the resonance. The system is not giving the property of the C double bond O. So we are going to discuss only the reaction of the aldehyde and ketone. Even in the previous reaction, we prepared the alcohol with the help of the aldehyde and ketone with the reaction of the Grignard reagent. Here we are going to prepare the alcohol with the help of the aldehyde and ketone directly, not with the help of the Grignard reagent. So a simple reaction is there. This is the aldehyde, CH3, CH2, CH double bond O, that is the propanol. When it will be reduced, hydrogen and palladium, a restricted reduction is needed, a limited reduction is needed. उसके लिए हम हाइड्रोजन और पैलेडियम को यूज करते हैं और आफ्टर द रिडक्शन वी विल गेट CH3, CH2, CH2OH. That is the primary alcohol, that is called propane 1-ol, a primary alcohol. But if you are treating the ketone with the same reagent, this is the ketone CH3CO, CH3, when it will be treated with the same reagent, hydrogen and palladium, the same process will take place. It will be reduction and it will form CH3CHOH. The propanone turns in the form of propane 2-ol, a secondary alcohol. So this is the secondary alcohol when we reduce the ketone, and when we reduce the aldehyde, it will be a primary alcohol. Next one, from ether. How will you prepare alcohol from ether? A simple hydrolysis process is needed for the preparation of alcohol. Just the hydrolysis of ether. This is the CH3, CH2O, CH2, CH3. That is ethoxyethane or diethyl ether, whatever you want to call. When you will hydrolyze H2OH plus, the hydrolysis of the compound will take place and it will yield alcohol. Here it is ethanol. Because it is a symmetric ether, it will yield the same alcohol, and if it will be non-symmetrical, it will yield the different alcohol, for which we need a separation technique. So it is better to use the symmetrical ether instead of the unsymmetrical ether. Then these were some of the process for the preparation of alcohol. In the next video, we will discuss about the preparation of phenol, and then we will discuss about the properties of the alcohol, like physical property, chemical property, and all the reactions. Till then, bye. Have a nice day. Thank you.